In this video we will make a sliding door with adjustable number of panels and can be opened and closed at any position. We can also adjust the door spacing from the edge of the wall on both the exterior and interior sides. This consists of two families. The first family is a single panel made in a generic model template, which is loaded into the second file. The second family is a door family. Open a new template generic model. Place two reference planes as shown and place aligned dimensions between the planes. Create an extrusion at the rectangle formed between the lines and lock the sides of the rectangles to the ref planes. Hold the extrusion and assign a family category doors to this extrusion. Hold the dimension and assign the respective parameters of the door family to the dimensions of the extrusion. Go to the front elevation and place a reference plane and place a dimension and assign the height parameter to it. Align the extrusion to the ref plane and lock. Hold the panel and assign a material parameter to it. Create a new family from a door template. Place two reference plane as shown. We want to place one reference plane at the edge of the wall. Place an aligned dimension between the center of the wall and the ref plane, and create a parameter half wall thickness. Hold the wall and go to Type Properties and create a duplicate family and change the wall thickness as required. In the box, write half of the wall thickness in front of the parameter. Place a lined dimension between the two ref planes and create a parameter panel thickness. Go back and load the first family into this file. Place a reference plane and place an aligned dimension between the edge of the wall and the new reference plane. Call this F1. Align the panel to this ref plane and lock. Align the lower edge to the edge of the wall and lock. Hold the panel and create associate parameters for all the parameters of the panel. Do not forget to make F1 equal to 0. Create a new parameter panel width and associate the width of the panel to this. Create a new parameter number of integer type and write panel width is equal to door width divided by number. Place a new reference plane and create a parameter between the F1 and the new ref plane. Make F1 equal to 0. Hold the panel and create an array. Align the edges to the ref planes as shown here. Hold the array and assign the parameter number to it. We want the panels to overlap even when the door is fully closed. So we have to an extra length to each panel. This length extra can be calculate d as shown. Add the extra to the panel width. When the value of closed is more than a certain value, the panels are opening more than the door width. Create a new parameter fully closed and write fully closed is equal to panel width minus overlap. When the value of closed is more than fully closed, the panels exceed the door width. Create a new parameter close and write the condition statement in front of closed as shown. So as per this statement, the value of close will never exceed beyond the fully closed value. If the number of panels is increased, the panels will go out of the width of the wall. So panel thickness can be designed according to the number of panels. The offset from the wall is 50 mm here. This can be made less or more as required. So how much is the door open? Write the condition statement for open.